Meteorologist Joe Bastardi here. That's the Atmospheric Avenger. That's during the week. This is the Saturday summary, so let's get that off. Okay, so anyway, let's start in 12Z tomorrow morning. The upcoming week looks like this. And the reason why you see this west-east streak of cold here is because the model thinks there's going to be snow on the ground. And there is going to be, because we've got a storm coming along. And the totals look like this over the next 5 days, as you can see there. By Monday morning, this all represents more than 2 inches of snow. You see, trying to come right into D.C. And the Monday morning rush hour in D.C. is going to be a pain in the neck. It'll be starting in Philly. And the evening rush hour in New York is going to be ugly, all right, up to Boston. Because what happens is this comes eastward, then starts exploding northeast for the following 24 hours from 12Z Monday to 12Z Tuesday. You can see where the more than 2 inches of snow is. So we're going to change over down here, and we're going to change the sleet and freezing rain in a lot of this area, stay all snow up at the top over here. But this is a very, very moist system coming up. There's going to be liquid amounts of 1 to 2 inches in here. And you take a place like where I am at State College, or let's say Rockaway, New Jersey, or Danbury, Connecticut. There's liable to be an inch of liquid, maybe a third to a half of it snow, and then a third to a half of it sleet and freezing rain, and then whatever's left over. Well, if you have 2/3, then you could have a third rain. But if you have 2 halves, then you get no rain. You know what I'm talking about. There's going to be a battle zone in there. There's going to be a royal pain in the rear end. Okay, if I might say that. Okay, may I say that? Okay, pain in the neck. And there's the totals, as you can see. And there's the freezing rain. You know, remember that Aerosmith song, Pink is my favorite color? Not when it comes to freezing rain. Although one may argue that's like, I don't know, what color is that? Fuchsia? I don't know. I have no idea. I never did well on the color charts. Here's snow on the ground the morning of the 24th. And so you can see it's sort of wiped out in the Midwest, just traces and piles and things like that. But then you get into the Northeast, mainly north of the Mason-Dixon line. Up in New England, there's snow on the ground. Of course, there's snow in the Rockies. There is going to be one heck of a cold shot into the Northeast. And it would not surprise me if temperatures hit the single digits all the way down to the suburbs of New York, northern suburbs, and into southern New England, 0 to the Massachusetts Turnpike, New York Thruway, and 20 to 30 below, maybe Friday morning over northern New England with this air mass that's coming down. You see all the warming going on here. Here's the European 7-day temperatures. You can see it sees the snow and the extreme cold in the northeastern part of the United States. I put that on before. I don't know why I put it on again. Okay, so here we are at 500 millibar. We use the European ensemble here. It's actually ensemble, but como ensemble usted. This is a positively tilted trough. Are you sure? I'm positive. Now, what does that mean? That means it leans northeast. This is more of a negatively tilted trough where the anomalies lean southeast. So what happens is, let me explain what goes on here. There's 2 things that lead to lowering of pressure. There's the upper divergence, air spreading apart, and there's what we call low-level warm advection. So the low-level warm advection term is just as important as the upper-level spreading apart term. So when you get these positively tilted troughs where there is a uniform amount of what we call vorticity advection, or the increase in the spreading apart of the air, all right, the air vorticity is spin. And if there's an increase in the amount of spin in the air, right, if the air is going from one state to another state, it creates different upward motion or sinking motion patterns, all right? So if it's all equal, what happens is it looks for where the warm air is. Now, if you get a high pressure moving off the eastern seaboard and there's a southeast and east wind, let's say blowing in here, downsloping off the Appalachians creates one area for warmth, and then the other area is right off the east coast. So what you'll see is a storm run right up the Ohio River Valley to about Parkersburg, West Virginia, Morgantown, and then it will jump off the east coast and exit south of New England, because of that. Now, you got to take a look at this. This is the UK Met, all right? Not to be confused with the UK Mutt, which is the British Bulldogs, who used to wrestle in the WWF. I know you used to watch the WWF or WWE or whatever it was back then. But the British Bulldogs, that's the UK Mutt. This is the UK Met. See this over Greenland here? When you get these Greenland blocks, in the east, the trough rocks. Okay, so that's going to shove this strong shot of Arctic air, just a piece, right into the northeast, right? Now keep your eye on this, coming into San Diego, all right? So we get out here to 120 hours, which is Friday. What's 120 hours? Is that 140? No, it's 120. That's a Thursday morning. So here comes the shot into the northeast. Squalls, all sorts of fun and games going on there. You'll be 20 degrees in the afternoon in Providence with the wind chill of 0, for instance, or something like that. Keep your eye on this, right? So we continue to move along here. Now, when we get to 144 out in the European ensemble, see, it doesn't know what to do with that. It has some up here, more of them down here. So there's a ridge in here. There's 2 big systems. You see, this is positively tilted, and this is the signature of the negative NAO. Here's your blocking over Greenland. And what generally happens with this is, you see that leaning back like this, there'll be some kind of feature in here that's stronger, and it'll want to put a trough right in over the mid-Atlantic states. So my theory is, when I look at all this, that the forecasted, this is the control run of the European, is wrong. What will happen is that this thing isn't going to go tailing down to Florida, in my opinion. It's probably going to be someplace over the mid-Atlantic states, and right in time for some fun and games next weekend. Okay? So along the East Coast, even though much of the nation will be warming up, along the East Coast next weekend, there is plenty of interest. Then you see it moving off. This is day 9. So that would be Monday morning. All right, so, and then, whatever's on the ground is on the ground. And then we get to next Thursday morning. And this is really interesting, because what happens is, when you get this kind of feature over here, something may try to cut through and then move off the mid-Atlantic coast Christmas night on into Thursday. And then we're out there at 360 hours. So we got sort of a fight going on here. This is the EPO, all right? Eastern Pacific Oscillation, when it's positive, like you see here, it generally leads to a lot of warm weather in the United States. But the Arctic Oscillation, I don't know if this is the Arctic or the North Atlantic Oscillation, they're both negative, and they're both signs for cold. So you got contradiction going on, and it leads to the models doing wacky things. I mean, it's like they're the wacky racers. Now, I know you watch the wacky racers, because I do. Well, I used to. All right. The wacky racers were great. Muttley was my favorite character. But in any case, there we are with Mutt again. UK Mutt, UK Met, Muttley. See that? This is all linked, folks. Somehow or the other, I tie it all together. But that creates a lot of fighting in the models, so they go all over the place. Now, one day they say one thing, one day they say the next thing. The GFS has cold, the European has warm. And when it comes to ensembles, you shouldn't have that much variance in ensembles. I mean, you should have some, but ensembles are supposed to wash you out the back and forths a little bit. So apparently it's not doing a very good job of washing things. All right, I realize I'm alienating all the solar lovers out there, and I get this impression sometimes that that a lot of people on my side of the global warming issue, and I may be completely wrong about this, they want to see it cool. They're looking for any sign of cool. Well, let me just say something. I'm cool. I'm really cool. I'm cooler than a lot of people think. No, but as far as that goes, you're not going to do it until you get rid of the warmth in the oceans. And the oceans are very much warmer than average. And so they put water vapor back into the air. And the super Ninos that go off put immense water vapor in the air. When it spreads out, it leads to a distortion of the temperature pattern. Now, eventually, if you keep going 3, 4, 5 cycles of low solar, it's, you know, if you believe in the total solar irradiance, then it probably is going to have some degree of cooling, but it's not going to happen in the coming decade of any significance. And we're right now running second warmest on record for December. I mean, you can't keep saying, "Oh, cool, it's cooling, it's cooling, it's cooling," it's above normal. And if we look at the 400 years of sunspot observations, people say, "Okay, we're going in the same kind of thing they had in the Little Ice Age, right? We're backing down." Look at this. You ran 200 years of the Maunder minimum up there, and you're going against 200 years of a modern maximum. If you're going to play the solar card, folks, if you're going to say that to me, say, okay, well, where's the heat stored from this? And I think it's stored in the oceans. Let's put it this way. I don't know if it's stored in the oceans, but it doesn't make sense to say that this, with this setup here, is going to happen again with this setup in front of it. May have nothing to do with it, but setups are very, very important. You could try to shoot a double leg takedown. If you don't set the guy up the right way, guess what? You're going on your back. If you set him up the right way, you get the double leg takedown. So this is like a good setup for a double leg takedown for those of you. Now you can go try this. You can go get someone and say, listen, let me try to set up my double leg. If you set it up wrong, it's not going to be a good thing. So what happens is, I hope you understand that analogy, because I'm working on this book, How Wrestling Affects the Weather. I think it's going to be a big book. In any case, this modern maximum over here, or as we say, modern max, looks like this, and we have the Maunder minimum. Maunder minimum versus modern maximum. That would be a good wrestling match. But the fact is, you don't have the same setup to drive temperatures down to those levels, at least not if you're talking about sunspots, all right, which is a great song by Bob Seger. Google it and listen to it, and you'll get all the answers. And again, I made this prediction back when this Super Nino came, that we were establishing a new higher pause point. There's a Super Nino in 97, 98, shoots tremendous amounts of water vapor in the air. That in turn spreads out, makes the biggest effect up in the Arctic regions, all right? And so far, so good with that forecast. We're approaching 2020 pretty quickly here. And even though it is definitely cooler, than what it was in 2016. So if I made a bet in 2016 that 2020 would be cooler, I'd be right, simply because it got so darn warm, right? It's not going down. And the more you keep pointing out, well, we had the quietest year on record, the more someone should be asking, well, how come it's so warm? There's where the argument starts. Oh, it's CO2. I don't believe that for a second. I believe it's, CO2 is part of the equation, but probably so small you can't even figure it out, right? But a lot of people think it's directly linked to it. I think it is the total picture, okay? Okay, total picture. All right. All right, that's it for now. I want everyone to just enjoy the weather, because it's the only weather you got.